Hello, welcome everyone to this research methodology workshop. I would like to thank all of you for participating in this workshop, and really thanks to Dr. Matt for delivering this workshop because he is too busy. And earlier he said, I'm principally okay with the workshop. But later on, I don't know the meaning of principally okay. Few of his students, they said principally okay mean not okay. But thank you, sir. Later on, he confirmed that he will deliver this workshop. Thank you very much, sir. Floor is over to you.
All right, thank you. So I'm very glad to have a chance to talk to you all today, and I'm kind of stunned at how many students have showed up. So I'm really happy about that. So I guess I would start by saying, I don't really know that much, right? So you don't need to listen to me, right? But I will give you a few tips on who I think you should listen to and what lessons we think I think we can draw from some of the great researchers that are out there, right? And I have a lot of kind of practical advice, I think, on how to go about finding a research problem, doing the literature survey, and things like that. So really, I think I would just like to share a collection of tips with you today, right? And of course, you're welcome to take it or leave it as it is, right? And actually, I guess more importantly, then I hope I'll talk for a little while, and then I hope that we can have some discussion. We can ask questions, and maybe I won't be able to answer them, but some of your peers can answer the questions and have some discussion. Yeah. So anyway, don't listen to what I say, right? So I'll give you, however, some advice on what are the kinds of people that you should listen to. Okay. Now I'm a computer scientist, right? So when I look for people to learn from, of course I'm going to go to some of the great computer scientists of the world, right? So be careful. These desks are not very good for computers. They tend to toss them onto the floor, so be careful. So I'll give you just a couple very nice references. These are kind of computer-centric, computer science-centric, yet they're excellent resources for research in general. So, and I'll pull some information out of these two particular resources. Okay. Now, by the way, Mihir Bilare's blog is actually called the PhD Experience, but the kind of things that we're going to talk about today apply to research at any level. Okay, from corporate research to senior project research, to master's thesis research, to PhD research, to any kind of research at all. All right. So, and if you find me talking about PhD and specifically, then you can tell me to shut up and be more general. Okay. So, what is research? So this is actually a good question. The word, well, it has two parts, right? Re and search, right? It means search again, doesn't it? Okay, that's what the English word seems to mean. But of course, research has a lot of I don't know, deep interpretation by different people, right? Coming from different perspectives. Anyway, so Mihir Bilare, he's one of my favorite teachers of all time, and so I really appreciate what he has to say on this matter. Now, Mihir Bilare, he happens to be a theoretical computer scientist. I'm not a theoretical computer scientist. I'm a very practical computer scientist. So again, some of the things he says are not really necessarily relevant to the kind of research that I do, or they might not be relevant to the kind of research that you do. However, I think he has some very interesting and useful perspectives. Okay, so anyway, so this is what he says, right? What's involved in research? So the most common vision is solving hard problems that nobody knows how to solve, right? That's probably our first idea of what research is all about, right? Trying to solve some great problem that people have been beating their heads against for centuries, yet have not yet been solved. Okay. So that is true to an extent, right? So hopefully all of you in your research are solving problems, right? I hope that that's what you one of the things that you aim to do. But the actual process of research includes a lot more than just solving problems. How can you solve a problem before you know what problem to solve, right? How can you solve a problem without knowing the techniques or technologies that will be useful to solve that problem, right? What if there's no theoretical basis for the solution for a particular problem, right? The problem might have to, you might have a human problem that somehow needs to be turned into a more technical or scientific problem before you can make any progress on it, right? So, so that's why research has a lot of different components besides just solving problems, okay? So at least what Mihir says, it's about conceptualizing, finding issues and directions, definitions, exposition, critical insight, right? So problem solving is just part of the problem, okay? So I want to spend more time today to talk about, how we can conceptualize of a research problem, right? How can we find a new issue to attack in a particular field of research, right? How do we come up with definitions or formalisms for that particular topic, okay? And eventually, after many steps, hopefully you're going to get down to the final problem solving, and hopefully you'll find a solution. I guess I should also mention the process doesn't end there either, right? Finally, even though you've solved the problem, and maybe you've done it in the most elegant way ever, right? And the performance of your solution is higher than any other previously proposed solution, right? Still, then, what do you have to do? I think you know what you have to do, especially if you're a doctoral student. Yes, that's right. So you have to put your work into a form that is understandable by others and seems like a novel contribution to your field by others. So we'll talk about that aspect of the research process as well, so publishing. Okay. So yeah, here's another little tidbit from Valari that I want to quote. Okay. So now again, some of this is related to theoretical computer scientists, right? So, but anyway, one common situation is developing a new model or notion. Okay. To do that, you have to make up definitions, right? And then you have to develop some algorithms and analyze that algorithm. Okay. Now, in just about every field of research, there are analogous things that you have to do, right? So if you're, trying to develop a new agricultural cultivation technique, right? Okay, so then still you have to come up with, you have to formalize the problem, you have to come up with a solution, you have to test the solution, you have to analyze the quality of your solution, right? Or your process, right? So anyway, when you're doing something new, and hopefully all of you are aiming to do something new in your research, right? When you do something new, oftentimes you might even be you might be a little bit worried that whatever you're doing is too simple. Okay, this is a very important piece of advice from Valari for us that we should not be afraid of simplicity. Okay, you should actually be aiming for the simplest possible solution to whatever problem you face. If your solution has unnecessary features, right? That are just maybe trying to make your solution more fancy, or I don't know, I'm trying to think of a good example, right? For example, suppose in computer science we have well-defined algorithms for search, right? So suppose that in order to make a new search algorithm, you do something kind of crazy and randomized, and you start from multiple points in your search space, and you have some weird rules for deciding when to go one way and when to go another, right? Finally, this kind of complexification is not what you should be aiming to do. Okay, so hopefully that makes common sense to most of you. What we want to do is we want to produce a very simple and very understandable and very elegant solution to whatever problem we're facing. Okay, so again, don't be afraid of simplicity. Okay. All right. So now this is my point of view on what are the different kinds of research that you that you might aim to undertake, and these are kind of, I think they cover most typical approaches to research. But some of them are more likely to lead to success than others, right? So anyway, let's take a close look at these different types of research. So number one is actually, this is the one that we all want to do, right? If you're a mathematician, you wanted to solve wanted to prove Fermat's last theorem, right? Or if you're an alchemist, you want to produce, was it gold from lead or something like that, right? Or if you're I don't know, if you're in agriculture, right, you want to produce the greatest seed that humankind has ever known, right? So anyway, so in every field we have these long-standing problems. In computer scientists, there's one called P equals NP, okay? And so yeah, if you can prove that P is equal to NP, or you can prove that P is not equal to NP, it would revolutionize all of computer science, okay? So there are probably hundreds, if not thousands, or even millions of computer scientists that have bashed their heads against this problem of whether P equals NP for decades, right? And have they gotten anywhere? Well, a few years back, there was a very complicated proof that someone had proposed, but it turned out to not be true, right? So anyway, yeah, this is probably not the direction that you want to go in your research, at least not at first, okay? Now, I'll talk a little bit later how you should not be afraid to tackle the great problems of your age, right? Whatever are the great problems facing the world, these really should be what we aim to tackle. But at the same time, you have to be practical, right? If you're a doctoral student, I said I wouldn't be too specific to doctoral students, right? Okay. So anyway, whatever kind of research you're doing, you aim to achieve some final product, right? Be it a research paper, right? Or be it a patent, or be it a product that you can sell, right? Whatever it is that you're trying to achieve, it should be, at least at first, it should be achievable, okay? Or even if the ultimate goal is something amazing, like to find out that P equals NP, then hopefully you can break that down into simple steps. That at least the first step should be achievable, okay? Now, this is especially true if you've only got, say, 1 year for a capstone project, or 1 year for a master's thesis, right? Then you need to make sure that at the end of that year, I've got to have something deliverable, right? I've got to have something that I can show to my committee, right? That I can use to graduate, right? So you have to be practical. So don't be afraid to get started on research like number 1, but yeah, just be careful and try to make sure you have a backup plan, which would be 2, 3, or 4. Okay, now, so the number 2, this is solving a long-standing problem with an innovative synthesis of existing ideas, okay? So here, what we're trying to do is, okay, there are some existing problems that are out there. There are, maybe heuristic solutions to these problems, right? And they work kind of, sort of okay, right? And then, in this case, what you're aiming to do is to try to find a way to put together a mix of existing ideas so that we can solve this problem a little bit better. In computer science, a little bit faster, or a little bit more accurately. In agriculture, maybe the product is a little bit tastier, or a little bit more productive, right? What have you, okay? So, so this is actually probably the type of research that most of you would want to tackle, at least, especially if you have a slightly longer period of time in which to do the work, right? You'd like to make incremental progress on some of the great problems that we currently face in your field of study. Okay, so that's number 2. All right, number 3. Solving an interesting new problem with an existing idea, or a new synthesis of existing ideas, okay? So in number 3, what we do is we come up with a completely new problem that nobody has thought of before, okay? Now this is much easier than number 2. Why? Exactly. Nobody has thought of the problem, so nobody has already solved the problem. So in a way, even the simplest, silliest solution to the problem will be progress, okay? So now you still have to ask the question, right? Is this a problem that the world wants solved, right? If the problem you're trying to solve is I don't know, how to make mice run upside down on the ceiling, right? Then maybe that would be useful for some purposes. Anyway, think about whether the new problem that you're proposing is it really something that we would like to solve or not. And we'll actually see how oftentimes these new problems, they do come up in the kind of approach to identifying a research problem that I'm going to argue for. Okay. So anyway, number 3 is a good way to get started, especially if you don't have much time for your research, right? If you have just a year, right? You're maybe a master's student or a senior undergraduate. Coming up with a completely new problem and then proposing the first solution to that problem. If it's a moderately important sounding problem, then people will accept it, and you'll have a good chance to reach a wide audience with that work. Okay. All right, and then number 4. So number 4 is kind of it's unfortunately, not the most respected direction for research, right? And that is solving a long-standing problem with existing ideas that haven't been tried on that problem yet. Okay, so a classic example in computer science would be to say, oh, okay, I'm interested in identifying breast cancer in images coming from an MRI machine. Okay, and so I do a literature survey. I see what people have done, and I say, people have not tried genetic algorithms yet, or people have not tried neural networks yet, or people have not tried, whatever is the latest fancy thing. Like, okay, there's one called ant colony optimization. Some of you might have heard of this, right? So different, maybe a different optimization technique for existing long-standing problem. Okay, so this kind of approach where you kind of look through what's been done so far, and then just try some variation. Just try to find something that's not been tried before, and then apply that solution to the problem, to this long-standing problem. It very rarely leads to high-quality output, right? And we'll talk about what I mean by high-quality output, right? Finally, if your goal is just to do something that is interesting to you, then you might well satisfy your goal. But like it or not, other researchers are not going to appreciate that kind of work. So be very careful if you're doing number 4. Yeah, actually, number 4 could be a path to success in certain circumstances. For example, maybe nobody thought to try this particular approach in the past, or maybe you actually need to modify this existing approach. Okay, is it working? Okay, I think my battery is dying already. Anyway, yeah, so it might lead to success if you have to modify the existing approach in order to make it work on this problem. Okay. Anyway, I would advise all of you that are getting started on a research problem, try to find problems that are more like number 2 and number 3, not so much like number 4. Okay. You have a higher chance of getting somewhere successful. Okay, so this is actually, I say this is a common mistake, is to get trapped into number 4, right? Due to lack of imagination, or you don't spend enough time planning your research, or whatever, right? You end up saying, okay, I'm gonna apply genetic algorithms. I hope nobody's applying genetic algorithms to breast cancer images right now, right? I don't think so, right? But anyway. You don't want to get trapped into that kind of research. So try to avoid it from the beginning and in a better situation. Okay, so now you're going to tackle some research. You're going to solve some problems. How are you going to determine whether you've been successful or not? Okay, in your own mind, right? Your gauge of success is up to you. You can define your success however you want. Maybe I'm just kind of a hacker, right? If I learn something, then I'm happy. Right? So then, could we maybe ask for a new battery for the microphone? Do we have another microphone? Okay. Yeah. So, then other things, right? A lot of the research topics at AIT have some of these characteristics, right? That they really could change the world in some really nice and nice way for society, making people's lives better, solving a new problem, right? So anyway, many of these types of success are within your reach. So I encourage you to aim for, to fulfill your dreams. Okay, so that's how you are going to define your success. Now the problem comes when it comes time for other people to judge your success. Okay. How you define your success is up to you, but how others define your success is not up to you, right? So how are they going to judge you? That's an important question. Okay, so this is the nasty side of research, right? Just being happy that you produce something new is not enough. So the measures of success that we have, now these are, I'm not saying these are the best ways to judge the quality of research or anything like that. It's just a fact that this is the way your research will be judged. So if you're going to become a professor, then when it comes time for contract renewal or promotion or whatever, this is pretty much what your administration is going to tally up in order to judge whether you should stay at your institute or get a salary increase or what have you, right? Every time I'm up for renewal, these are the things that AIT calculates, right? And sees, okay, is Matt, is he doing okay or is he falling behind, okay? So the first one is publications in journals with high JCR impact factors. Okay, so we can talk more about what impact factor is. I think a lot of you know about it already. And then the second one, thank you.
Okay. And the second one is citations. Okay, so I think you know what a citation is, right? When we write a paper and we draw ideas or get information from other sources, we have to cite those sources. The sources that we cite are normally going to be the ones that are most authoritative in that particular area. Now, that also is not always true, right? Sometimes you cite a paper because the approach in that particular paper really sucks, right? And you're going to do much better than that, right? So some citations are not necessarily good citations, right? So if you count your own citations and you see that maybe 90% of them are negative citations, then you might not be so happy. But actually, you could also say that infamy and being infamous and famous are the same, right? So that part is up to you. Yeah. So anyway, research, metric, organizations, and your administration, and a lot of people are going to judge you by how many citations there are to your published work. Okay. So it behooves you then to first of all publish your work in places that are likely to get a lot of citations, right? And that means publishing your work in the same thing, these journals with high impact factors, okay? So generally, you want to do the research in a way that satisfies your own
measures of success, but it would also be good, right, to try to maximize your potential from the point of view of others, right? And so that means publishing your work in the most prestigious possible venues. Okay, this will not harm you, right? It might take longer for your papers to get published and so on, and it might not help you, but it probably will, right? If you publish in in my field, some of the top journals are these IEEE transactions, right? So IEEE covers many fields of study here at AIT. And so, yeah, if you publish in IEEE transactions, people will be more likely to listen to you and more likely to cite you than if you put the same paper in the AIT International Journal of Computer Studies. Right? Now, we don't have such a journal, right? But if we did, right, some people would read it and enjoy reading it, and I'm sure there would be lots of high-quality research in that journal. But ultimately, fewer people would read it, and fewer people would cite it. And so that means that these people that are judging you by your citations are not going to be as impressed by your work as they might otherwise be. Okay? So don't shoot yourself in the foot by publishing your work in places where nobody's going to read it. Okay? Do your best to get it published in in the most prestigious possible venues. Now you might say that this publication game, it really sucks, right? It's just a game, right? I submit to these journals and it's all meaningless, right? Actually, why don't I just publish my paper on my own blog, right? And then the people that are interested will come read it. And that's a legitimate point of view. But again, if that's the approach that you take, you might have more time to do research, right? That might be good because you're not trying to constantly please these reviewers and so on. But I think you'll find that getting feedback from peer reviewers at these top journals, using that feedback to improve your work, right, and playing their game, in the long run, it will benefit you as a researcher. Okay, that's my opinion. Now you're free to ignore that or take your own approach. Okay. All right. Now another way to gain attention for yourself and therefore hopefully get more citations is also to present your work at conferences. Okay. Now, conferences are kind of a strange beast, right? These international conferences they're quite variable, right? Some are well-known. What can we call them? Junkets. Do you know what a junket? This English word junket means? Anybody know what a junket is? Okay, a junket is kind of a official trip that you go on, where the purpose is not really anything official, but to go to some beautiful place and relax at the beach and I don't know, drink wine and have a nice time with your friends, go on tours, go shopping, right? Then you come back to your hometown, to your university and give out gifts and everything, right? So that's a junket, that's an academic junket, right? And so many conferences are academic junkets, okay? So, so definitely if you are, you know, going to, I don't know, places like Bali and in Thailand maybe Krabi and Phuket and I don't know, you know, exotic places all over the world, right? If those are all the conferences on your CV, right, then people are not going to take you very seriously. They say, this person just loves to travel, go to conferences, right, have fun. They're not serious about research, okay? So how do you select the right conferences to publish in? Now, I should mention that this is a little bit different in computer science and maybe electronics, embedded systems. The computer-related fields tend to take conference proceedings much more seriously than other disciplines, right? So, for example, in I don't know, in you know, humanities and social sciences, for example, a conference is just a place that you go to meet other researchers and present your work, right? And so there's not really any serious peer review of your work before you give a presentation. However, at top conferences in some of the engineering fields, in order to have a chance to present your work at that conference, there's a rigorous peer review process, right? And in some conferences, only 10% of the papers submitted are accepted, right? Or 20%. So very difficult to get into these conferences. And then the work that is presented there tends to be very high quality, and you learn a lot by going to the conference. So the top researchers in the field go to those conferences, and so it's your chance to present to other great researchers in your field, to meet a lot of people. So it's a very positive experience. So if your discipline has top conferences like this, then really one of your chief aims as a research student should be to try to get your papers into these conferences, right? If you can do that, then you're almost guaranteed a path to success. You know, if you can get your paper into a top conference, you'll definitely get it into a journal with high impact factor, right? If you do that, then you'll definitely get lots of citations, right? So anyway, these aspects of you know, external measurement of success in research, you can see that they're a little bit arbitrary and probably can be gamed, right? So there could be some unscrupulous people that only you know try to maximize their impact factor, don't try to produce great research, right? And try to get a lot of citations without you know, without being serious about research. However, I think generally these measures do encourage, you know, if you adapt your approach to try to maximize these measures while doing good work, then you'll be in a good situation. Okay. Yeah. So that makes me mention that yes, these measurements can be gamed, but if you do your work, if you do great work, and you do that great work with integrity, then you don't have to worry about people gaming the system, because you will get rewarded accordingly. And we'll talk a little bit more about that. Okay, so how can I do great work? So here's where I would definitely encourage you to visit this. It's actually a talk that Hamming gave at Belcourt many years ago in the 1980s. Okay, so Hamming was one of the great people and computer scientists, particularly in the telecommunications revolution, right? And he gave this wonderful presentation at Bell Labs, or was it Belcourt? I can't remember. Anyway, back in the 80s, and so people and computer scientists tend to come back to this essay, right, or this talk, and read it for advice. So what his main thesis is that to do great research, you have to have courage. Okay, so you have to have courage to attack the
Problems.
I think this one's also going, I don't know why. The courage to attack these big important problems, okay? So, you know, in his case, it might be, you know, how to send data as fast as possible with minimum distortion, with no distortion, right? But then, okay, what's the problem? What are the big problems of today? Computer science, it might be P equals NP or not, right? Or you know, perfectly secure communication, etc. Right? So these are some of the you know, problems of your discipline that you should be trying to figure out if you have an attack. Okay. So anyway, so Hamming goes to great lengths about how to select a great research problem and how to make progress on a great research problem. So I encourage you to look at it. But the first is to have courage. The next one, I didn't put in the slide, but he also talks a lot about being independent, right? Don't believe what other people say. Try not to think the way that other people think, right? Think about different ways of solving problems, different ways of approaching things, right? But finally, even Hamming will tell you you have to be practical, right? If you're always just dreaming about these the great problems of our time, right? And you're not being practical about it, then you're not going to make progress on those problems. Okay, so the way that he puts it is that you have to find the right problem, and the right problem is the one for which you have an attack. Okay, so you know, you think about whatever problem you're trying to solve. If you have absolutely no idea of how you might go about solving that problem, right? Even after thinking about it for quite some time, then it's probably not worth. You're unlikely to be successful in going about the solution of that particular problem. Okay. So you have to at least see some kernel of an idea of how you might approach that problem, right? If you can't see that initial glimmer of light that might lead toward some solution, then don't go down that path. That's what Hamming says. Okay, so that's what I mean by being practical. So work on great problems, but at least make sure that you have some way to approach the problem before you spend years beating your head against such a difficult problem. Okay. Another thing that I have to mention is integrity. So this is actually very important, right? If you want people to believe that you're serious about research and that you want people to pay attention to what you have to say, so that they will, read your work, they'll refer to it, cite it, and so on, then you need to do your work with strong integrity. Okay. So these are some of the things that I advise my students to do, right, and how to behave and how to work, right. So always being honest in how you present your work. Okay. Now, how would you be dishonest, right? Well, it's actually possible for most of you, right, since most of you are working oftentimes individually, right. You're working maybe you're working with one.
Professors as advisors.
Is it going to come back? Okay. You're working with some professors as advisors, and actually, in the end, you're doing evaluations and measurements and so on. And so really, the measurements that are coming from your work, right, they're yours. It would be very easy to do
what?
What would be easy to do, but would not be ethical. To fabricate your data or modify the data. Right? This is, it'd probably be easy to fool your advisor, and then once you have your advisor convinced, right, then your advisor will help you convince the journal, right, and then you get published and so on. But obviously, this is a bad road to go down, right, and this leads to disasters in the careers of some very world-renowned scientists, right. When it's discovered that you fabricated data, the consequences are very dire. Okay, and besides, even if you're never caught, right, you're doing the wrong thing. So be honest, right? If you succumb to this kind of temptation, I don't think anybody at AIT would ever do this. I hope, right? But anyway, this is very important to keep in mind. Always be honest. Okay, another thing that smacks of lacking integrity is overselling your work, right? If you make some moderate improvement on the state of the art, and then you go out and try to sell it as the greatest thing that's ever been done, right? And just keep telling people how wonderful it is and how great you are, right? This is another way that lacks integrity, right? You should be honest about the impact of your work, okay? If your work is modest, you can be admit that it's modest, right? If your work is wonderful and fantastic, people will immediately see how wonderful and fantastic it is. You don't even need to tell them other than to present the work to them, right? Okay, aim to have real impact in your work, okay? So this is kind of like avoiding research topics like number 4, right? Just doing something for the sake of doing something new. Try to avoid that approach to research, right? What you want to do is you want to solve a problem that people want solved, right? That will improve performance in your particular field of engineering, or will solve some of the great problems facing society, right? So this is your ultimate aim, is to solve problems that people care about, okay? So try to achieve that. Don't try to kind of fritter around and, okay, there's this concept of a minimal, what is it? A minimal unit publication. A minimal unit of publication, MUP, a MUP. I just made up that acronym, but anyway, a MUP is some very, very, very small research outcome, kind of the smallest possible research outcome you could imagine that might get published, okay? So you want to avoid approaching research and publication in this way, right? Aim for something great. Try to achieve something significant before you try to sell it. Don't oversell work that is not that is not as amazing as you're making it out to be. Okay, do what you say you will do. Okay, so that's kind of an attitude, right? That be honest, try to do. Okay, I often say, in principle, I will give a talk on research methodology next month, right? I might not be able to do it, right, because I get too busy or something like that. But try to keep your commitments, right? To do what you say you will do. This is an important aspect of research and collaboration with other people. Next, give credit where credit is due. Okay, now this is something that all students, especially initially, have trouble with, right? Almost all students have trouble with properly giving credit where credit is due, right? If you take ideas from other places, then you need to give credit to those original innovators that is the principle of standing on the shoulders of giants, right? So you don't have to try to be the giant, right? You have to stand on the shoulders of the giants in order to reach higher, right? So when you pull in other ideas from other places, you need to be honest about where you got the idea. That okay, I'm not doing something completely new. I've modified this solution due to this other researcher in the past, right? So don't try to avoid giving credit and giving credit to yourself where it's not. Okay. All right. Submitting to a conference. Okay. So now, because of these number games that I mentioned before, right? In some cases, having publications and conferences might look good on your CV, right? And so it might help you to get a promotion. It might help you to get a salary increase at your job, whatever, right? But okay, although that might be a positive impact of publishing in a conference, that's not the goal of publishing in a conference, right? The goal of publishing in a conference is to get out there, to show your work to others, to get honest feedback from others, so that you can then improve your work, right? So that's the goal of submitting to a conference. So sometimes I see that people, this is not only students, but sometimes professors also, not here of course, right? Not at the OT. Sometimes the researcher will submit to a conference, and then when the paper is accepted, will say, oh, but I don't have enough money to go travel to the conference and present it. So I'm just going to let the paper appear in the proceedings, but I'm not going to go. Okay? This is an extremely bad thing to do. Okay, so don't do this. If you have the intention of doing this before you start, please don't submit to the conference. It will ruin your reputation. Okay? It will ruin your reputation. If you submit to a conference, you should submit with the intention of going and presenting the paper at the conference. Seems better already. Okay. Okay, submitting to a journal. Okay, here the goal of submitting to a journal is communicating some important work that you've done to other people, right? So it's not to have an entry on your CV, right? It's not to increase the number of impact factor points that you can claim towards promotion, right? The point is to communicate your technical work, right? So you have to approach that with an honest and sincere determination, right? What do I mean? Maybe it's not clear what I mean. So one thing that comes up now and then is that you hear about people that submit the same work to multiple journals simultaneously, right? Same paper to 2 journals. Is that allowed?
No.
It's not allowed, not by AIT rules and not by the rules of academics. Now, why would someone want to do that? Exactly, save time, right? So you say, okay, I've done this wonderful work, but if I submit it to these journals, right, they're going to take a different amount of time to review the work, right? My paper's not going to get published for 1 year or 2 years or 3 years or 4 years, right? Oh my God, how can I, you know, kind of get a jump start on that, right? Okay, so then maybe it's the shotgun approach, right? So you send the same paper to a bunch of different places, and whoever takes it first, you say, okay, I got accepted, and then you can retract it from the other places. Okay, don't do this. It will ruin your reputation, and anybody that finds out, you know, will know that you have no integrity in your work, because it's clear if you're doing this that your goal is to get something in print in order to put something on your CV or to get some other personal benefit, maybe even graduate earlier, right? That's not a legitimate reason to send a paper to a journal. You should send a paper to a journal because you want to communicate your work to the world, okay? So if you approach it in this manner with integrity, then you won't make these mistakes that sometimes beginning researchers or ill-educated researchers sometimes make, okay? Lastly, don't do anything you're not proud of, okay? So for example, if you send a paper to a weak journal, right, because you think it might get accepted even though it sucks, right? So you spend one week on the paper, you send it to a bad journal, and you just pray, okay, if I'm lucky, they'll just accept it, right? And then I have an entry on my CV, right? Again, don't do that kind of, if people see that you're doing this, you will lose your chance to be seen as being someone with integrity. Right? So you'll immediately, you basically ruin your career as a researcher. Okay. All right. So so those are some very important aspects of doing research with integrity. So I hope you don't mind that I spend a long time on those aspects, but I feel they're extremely important. Okay. So now we talked about some of the, you know, what is research about, what's the goal, how are you going to be measured, things like that, how should you approach it philosophically, right? So now let's get into a little bit more nitty-gritty about how you might actually get started. Okay, now I know many of you have already started on your research program, some of you have already finished your research programs, but some of you are just getting started, so I hope that some of this advice would be helpful. So if I go to Bilari's paper or his website, I find that this is a really nice way that he does things, right? So he works with students, okay, and so he tries to start off with a very well-defined project that has a very strong chance of leading to a decent publication if completed, right? So in this case, well, Bilari, he's a very, very smart guy. He probably already knows what the solution to the problem is, right? So he gives his student such a problem, right, that if they can solve it, they'll have a pretty good paper, right, and get it published. And then that would give them some experience that they could then build on, okay? Second phase, right, so a suggested project, but it's not so well defined, more fuzzy, right? So then the student has to solve it more or less on their own. And then finally, the student is on their own, right? So that's his approach to building a researcher, right, is to basically hold their hand in the beginning, right, and then gradually let go of that hand. So if you're having trouble getting started, then you should find a mentor, not necessarily an advisor, but a mentor who will be able to do this for you, will be able to help you identify what is a problem worth solving that can likely be solved in the period of time and with the skill set that you have, right? So find a mentor that can help you to identify these kinds of problems. Okay, and then once you get started and as you start to get some research experience under your belt, then you can start to look for your own problems in a more independent way, right? So you're always aiming to finally get to the point that you okay, after learning as much as you can from your mentors and from your seniors and from your advisors and so on, then it's your job to strike out on your own, find your own problems and find your own solutions. Okay. So anyway, so that's how Bilari gets started with his students. So here's this is my way of finding a problem and getting started in attacking it. It's in some ways it's the same, but in other ways a bit more applied. I do happen to do more applied research, and I hope that you can adapt some of these techniques or other techniques that you find online, right, to your own particular discipline, right? So first, I like to start with a practical problem that needs a solution. Okay, so you know, every field of study or every field of research has some, you know, problem that needs to be solved, right? That you would like to solve. These could be quite mundane problems, right? But that are not yet solved, right? Or they could be you know, very incredibly difficult problems, right? So for me, for example, I work in computer vision. So one of the problems like this that I always dream about is getting robots to see. Okay, there's a very simple getting robots to see. A four-word research topic, right? Getting robots to see. Right now we have lots of robots. We have lots of robots with cameras, right? But none of them can see, right? So this is my lifelong ambition and lifelong dream, is to get robots to see. So you should have some dreams like that, right? Okay. Now, okay. So once you have a great problem in mind, the next thing to do is to figure out what's already been done to solve that great problem. And this could be a thought experiment. Not necessarily. You don't have to go spend, you know, days in the library or you know, days on the internet looking around and seeing what's been done. Just think about what's already out there that is a partial solution to this problem, right? So okay, getting robots to see. Clearly we have good robots, we have high quality cameras, right? We have lots of computation power. What's missing? The algorithms, right? So all we need is a wonderful algorithm that will help robots to see, right? So think about it in that way for your own great problem. Okay, so next, so then you find the gaps. So what are the gaps? The gaps are the pieces of the puzzle that you've constructed in your head that are not there yet, right? So, you know, in the case of getting robots to see, you can only find an algorithm that can go from an image to some, you know, three-dimensional model, right? That will tell a robot what's out there in the world, right? Then I will have solved this problem. So the algorithm is the gap. I'm simplifying things just for making things, trying to make things a little bit clearer. Okay. So what's missing, right? That's the gap. Okay. Actually, when you go into detail, you'll find many little pieces of the puzzle. Many little pieces of the puzzle that are not quite solved yet, right? And so each of these little pieces of the puzzle that is not quite solved yet is a candidate problem for you to tackle in your research, okay? So every gap corresponds to some technical work that is not yet there, right? That is not yet available. So if you can fill in that gap, then what you've done is you've taken us one step closer to solving the great problem that we're trying to tackle. Okay. Now, some of these problems that you might consider trying to solve will be just completely indomitable. You won't have any idea how to approach that particular problem. However, based on your existing knowledge and understanding, especially your fundamental skills, right, that hopefully you've been learning all through your educational career, you'll see an attack for one of these problems, hopefully, okay? What is an attack again? As we talked about before, it's the glimmer of a possibility for an approach to solve that very small, well-constrained you know, problem that represents some gap in the current technology or solution set. Okay, so all right, now there's a really strong temptation at this point of identifying problems to go out there on the internet and find out what other people are doing. Okay? Now, this is very important to understand what other people are doing, but now is not the right time. Okay? Now is not the time to go read 1,000 papers on the internet, right? There will be that time. It's coming. It's number something, right? Number 6, okay? But at this stage where you're just trying to identify the problem, I think it's really important that you think before you read, okay? So you can actually maybe write this down, okay? I like to tell my students sometimes you should write things down and put it under your pillow as you go to sleep at night, and then maybe through osmosis it'll really sink into your brain, right? Okay? So think before you read, okay? Why? Anybody have an idea why I would say such a thing? Why not read everything first? Okay. Yeah, okay, that's right. So, yeah, the more you read, the more biased you will be toward going in the particular direction that people have gone before, right? You know, it's like, you know, if you're standing in a forest, right, and see a couple paths going away from you, then you won't think of any other way to get through the forest. You'll have to select one of these paths, right? So if you don't read too much before you really start thinking deeply about a problem, then you'll not be so biased, right? You'll actually be able to see, oh, when I see this particular solution that's already been proposed, if I've already thought about the problem, I can say, I bet my idea is better than this one, right? Or maybe okay, my idea is not quite as well thought out as this one, but it's a candidate alternative approach to the problem. It might be better, right? Or if I modified my approach, then I might be able to do better than this existing approach. However, if you don't think before you read, you'll never be in that you'll never have that point of view. You'll say, okay, these are different ways of solving the problem. So now I see, okay, attack A, B, C, D. Which one looks best? C looks best. Okay, now I'll go and look at C. Now how can I make C better? Right, now you've already locked yourself into a particular approach that maybe you could have avoided that entirely if you had thought about the problem more before you started reading. Okay? So this might be a little counterintuitive, might be a little crazy, right? To say, okay, don't use the internet, right? Use your brain instead of the internet. But I hope that you get the point, right? That reading too much before you think will bias you in some deleterious ways. Okay, so think first, then read. Okay, and you should read a little bit first, right? Don't read too much, right? I had some students who couldn't start working on a problem until they had read all the textbooks on that particular topic, right? So they get bogged down reading books forever, right? So then I have to finally, look, stop reading, start doing, right? This doesn't affect everybody, but it's another trap to avoid, right? Don't read too much. You have to find some happy medium between studying, learning from others, and trying things yourself, right? So now, if you only try things yourself, that's another stereotype of a researcher that doesn't pay any attention to what other people are doing, and that's also a bad track, right? Because that will lead you down some path that finally, because you haven't done your homework, right, nobody's going to listen to you, okay? Unless, of course, it could be a truly amazing, wonderful, great discovery that you eventually make by taking your own path. This is the way to reach level 1 research that I was talking about before. You ignore whatever has been done in the past, and you blaze your own path. Okay, this can be very productive if you're a genius, and it can be very productive if you're lucky, right? But if you're not lucky and you're not a genius, right, then you're just going to be in trouble, and nobody will listen to you because you're not in touch with the way that the researchers in that particular field approach those problems. So anyway, you can read too much and you can read too little. So you have to find the way to read the right amount, okay? So my advice is to read a little bit, try some things, read a little more, try some things, read a little more, try some things. Never stop reading, but never stop trying also, right? Okay. Now, you have to read broadly, right? So if you just do Google searches on your very, very specific topic, then you're only going to find a few papers or books related to that particular topic, right? So you should be looking at all kinds of different things that might help you in your analysis and solution to the problem, right? So, if you're I don't know, if you're in computer science, you might study techniques from economics or from physics, right? As possible solutions to a problem. Sometimes the best research comes for when someone is able to bridge the divide between different disciplines and pull together ideas from different areas. It's particularly true in computer science, right? Physicists and economists, maybe sometimes psychologists even can have tremendous impact.
Is it working? Is it working? Can you hear me? No. I think it's sort of working, but not quite, right? I think this one's better actually.
Okay, anyway, we'll make do with this. All right. Yeah, so what was I saying? Yeah, so reading about techniques from different fields can be very, very profitable, although it's also very difficult sometimes, because usually if you're trained in one area and then you try to read the work in another area, it's like learning a foreign language. So for example, if I go try to read economics, it can be very difficult sometimes because I don't have all the background. But when you're starting your research career, when you're just starting out, this is the very best time to learn a new field or a new discipline or a new area. It's when your brain is at its youngest, it's least biased, it's the least confused by having to do administrative work or heading a department or having to supervise students or running research projects, right? You're only faced with 1 or 2 or 3 problems, right? Not 20, okay? This is the time to drink deep, right? To really get a lot of ideas from a lot of broad areas of science and engineering or whatever is your area. So yeah, read broadly. Okay. So anyway, as you read, then you come back and you try things out, right? In terms of solving your own problem. So go back and forth, as I said. Don't get stuck on either one, and don't be afraid to change your solution. Also, right? When you finally read about something that is clearly going to be better than part of your solution to the problem, then yeah, adopt the best practices that are going to lead you to your best solution. Okay. Another important aspect is getting scooped. Okay. Anybody know what being scooped means? Ah, that's right. Someone else publishes your work. Not exactly, but someone else has kind of the same idea, right? And they publish something very similar to what you're working on before you do. Yep. And this happens. It's it can be very depressing, right? You spend, especially if you're a doctoral student, but even if you're doing a senior project or a master's thesis or whatever, you spend a year or a semester or anyway many months on a particular direction of the research. You know that it's going to revolutionize the world when you finish. Then you're halfway there, you're 2/3 of the way there, and you're starting to think about where you're going to publish and so on. And then you happen to check your favorite journal, and you see that an article proposing a solution very similar to the one you've been working on all these years has just been published. Okay, and then that means what? It means you might still be able to get your work published, but it's suddenly much more difficult, right? You have to distinguish yourself from the previous work every time you submit a paper, and if you're unable to do that, then the reviewers and the editor will not accept it. Okay, you can still be happy for yourself, right? But again, in terms of these bean counter kinds of metrics of how successful you are in research, you'll be measured as less successful, right? So, so you should actually look for the trends in the literature, right? If you see that the literature is leading already to your idea, then you're probably, you're probably about to get scooped, right? One technique that some beginning researchers sometimes propose is, okay, I'm going to read about all of the solutions to this problem, and I'm going to look at the future work in every one of these papers, okay? And then I'll say, okay, that's probably, so I'm interested in robot vision, right? And so I read some of the robot vision papers, and I see their techniques, and I say, okay, in future work, we will extend this method to include dynamic objects, or some whatever, right? So I say, okay, I'm going to go solve that problem, right? Well, first of all, if it was easy, then the researchers who proposed that as future work are probably going to get there before you, right? unless you're very fast. That might be a way to beat them. But anyway, this is probably not the best way to go about it. You should try to find an approach or a problem that is not just on the verge of being solved by others. That's because that will, yeah. Anyway, that'll be bad for you. Don't get scooped. Okay, so now I want to come back to thinking again. This is from Dailey again. So I can't stress enough how important thinking, as opposed to just reading, is, right? Thinking for understanding and depth of understanding. So he says the first rule of research is to think, and think again. Okay, never hesitate to throw your mind at anything. Okay, that should be the first thing. Don't. So this is the same thing I was saying, right? Before you go to a book or a paper, think about the solution yourself, right? Try to find what you would do first, right? Don't be lazy about thinking, right? Thinking is how you build up understanding, and finally you'll come up with a bag of techniques for solving problems in a more they'll be your techniques rather than some other technique that you read about, right? Okay, and if you don't find this fun, if thinking is not fun for you, then okay, go. Is there any job in the world where you don't have to think? Maybe flipping hamburgers at McDonald's or something like that, right? That's what we say in America. I don't know. In Thailand, what would be the equivalent job? I guess we have McDonald's here too, right? Okay. Anyway, all right. So you identify a problem. You're thinking hard every day. You're not reading too much. You're thinking. You're reading. You're solving. You're coming back to reading. You're making progress, right? So how are you?